Network topology. Network topology refers to the physical and logical arrangement of nodes and connections in a computing network. Physical topology describes the layout of devices and cables, and logical topology describes the way in which data is transmitted within the network. Regardless of the physical layout, physical and logical topologies plays an important role in the overall performance, scalability, and security of network. Each topology has its own advantages and disadvantages, and the choice of topology depends on the specific requirements of the network. Point-to-point topology is a permanent link between two endpoints. Switch point-to-point topologies are the basic model of conventional telephony. The value of permanent point-to-point network is unimpeded communication between the two endpoints. Bus topology. It is a network type in which every computer and network device is connected to a single cable. It is a bidirectional, it is a multi-point connection, and non-robust topology, because if the backbone fails, the topology crashes. In bus topology, virus MAC or media access control protocols are followed by LAN's Ethernet connections like TDMA, Pure OLAHA, CDMA, SLAT OLAHA, etc. Advantages of bus topology. 1. It is cost-effective. 2. Cable required is less compared to other network topology. 3. Use in small networks. 4. It is easy to understand. 5. Easy to expand joining two cables together. Disadvantage of bus topology. 1. Cables fails, then whole network fails. 2. If network traffic is heavy or nodes are the more the performance of the network decreases. 3. Cable has limited and length. 4. It is lower than the ring topology. Ring topology. It is called ring topology because it forms a ring as each computer is connected to another computer, with the last one connected to the first. Exactly 2 neighbors for each device. Features of ring topology. A number of repeaters are used for ring topology with large number of nodes, because if someone wants to send some data to the last node in the ring topology with 100 nodes, then the data will have to pass through 99 nodes to reach the 100 nodes. Hence, to prevent data loss, repeaters are used in the network. The transmission is unidirectional, but it can be made bidirectional by having two connections between each network node. It is called dual ring topology. In dual ring topology, two ring networks are formed and data flow is in opposite direction in them. Also, if one ring fails, the second ring can act as a backup to keep the network up. Data is transferred in a sequential manner, that is a bit by bit. Data transmitted has to pass through each node of the network till the destination node. Advantages of ring topology. Transmitting network is not affected by high traffic or by adding more nodes, as only the nodes having tokens can transmit data. Cheap to install and expand. Disadvantages of ring topology. Troubleshooting is difficult in ring topology. Adding or deleting the computers disturbs the network activity. Failure of one computer disturbs the whole network. Star topology. In this type of topology, all the computers are connected to a single hub through a cable. This hub is the central node and all other nodes are connected to the central node. Features of star topology. Every node has its own dedicated connection to the hub. Hub acts as a repeater for the data flow. Can be used with twisted pair, optical fiber, or coaxial cable. Advantages of star topology: fast performance with few nodes and low network traffic. Hub can be upgraded easily. Easy to troubleshoot. Easy to set up and modify. Only that node is affected which has failed. Rest of the nodes can work smoothly. Disadvantages of star topology: cost of installation is high. Expensive to use. If the hub fails, then the whole network is stopped because all the nodes depends on the hub. Performance is based on the hub, that is, it depends on its capacity. Mesh topology: each node is directly connected to some or all the other network nodes in a Wi-Fi mesh system. The redundancy makes this type of topology highly fault tolerant, but it requires more bandwidth and it can be expensive to implement. Advantages of mesh topology: communication is very fast between the nodes. Mesh topology is robust. The fault is diagnosed easily. Data is reliable because data is transferred among the devices through dedicated channels or links. Provides security and privacy. Drawbacks of mesh topology: installation and configuration are difficult. The cost of cables is high as bulk wiring is required, hence suitable for less number of devices. The cost of maintenance is high. A common example of mesh topology is the internet backbone, where various internet service providers are connected to each other via dedicated channels. This topology is also used in military communication systems and aircraft navigation system. Tree topology combines characteristics of linear bus and star topologies. It consists of groups of star-configured workstations connected to a linear bus backbone cable. Advantages of tree topology: extension of bus and star topologies. Expansion of node is possible and easily managed and maintained. Error detection is easily done. Disadvantages of tree topology: heavily cabled, costly. If more nodes are added, maintenance is difficult. Central hub fails, network fails. Hybrid topology is a type of network topology that uses two or more other network topologies, including bus topology, mesh topology, ring topology, star topology, and tree topology. Advantages of hybrid topology: reliable as error detecting and troubleshooting is easy. Effective. Scalable as size can be increased easily. Flexible. Disadvantages of hybrid topology: complex in design, costly. Network topologies used in artificial intelligence or AI and machine learning. Feed-forward neural networks. These networks consist of an input layer, one or more hidden layers, and an output layer. Data is passed through the network in one direction, from input to output, and there are no feedback loops. Convolutional neural networks, or CNNs. These networks are commonly used for image recognition and classification tasks. They use convolutional layer to extract features from input data and pooling layers to reduce the size of the input data. Recurrent neural networks, or RNNs. These networks are commonly used for sequential data such as text or speech. They have feedback loops that allow the network to use previous predictions as input for subsequent predictions. Long short-term memory, or LSTM networks. These are a type of RNN that can maintain a long-term memory for previous inputs. Autoencoders. These networks are used for unsupervised learning and data compression. They consist of an encoder network that compresses input data into a smaller representation and a decoder network that reconstructs the original data from compressed representation. Generative adversarial networks or GANs. These networks are used for generating new data such as image or text. They consist of two networks, a generator network that generates a new data and discriminator network that attempts to distinguish the generated data from real data. Transformers. These networks use for self-attention mechanism to selectively focus on different parts of the input data when making predictions. They are commonly used for natural language processing tasks such as language translation and text classification. Network topology and opacity. In the most modern systems, networks have become so complex that traditional topologies now apply in different ways. One of these phenomena is the use of opaque systems to foil hackers or outside server attacks. Some experts now suggesting by shielding the IP address and isolating different parts of the network into segments. Companies can practice better cybersecurity hygiene. All of that continue to change how network topologies are used.